1 million.
It's a nice, round, slightly terrifying number.
It is a staggering number. And just so we're all on the same page, we are not talking about dollars here or users or lines of code. We're talking about satellites. A new filing is proposing putting 1 million active satellites into orbit.
And just to give that some perspective, because our brains are, terrible at picturing a million of anything. Before this current satellite boom, let's say before 2019, humanity had launched fewer than 10,000 satellites in our entire history.
That is a Sputnik.
Total. So what we're talking about is doing 100 times all of spaceflight history, but all at once.
It breaks the brain a little bit.
It does.
And that's exactly why we're doing this deep dive today. We've got this stack of documents here, a new filing. It seems to be coming out of the Musk sphere of inflows. And it's not just about, more internet. This is something completely different.
Oh, absolutely not. If you actually read the technical specs in the source material, this is not Starlink 2.0. This is not an upgrade. It's a fundamental pivot in what we're even putting in the sky.
It's the difference between a cell tower and a supercomputer.
That's a great way to put it. We're going to unpack this transition from simple communication relays to what the sources themselves are calling orbital data centers. And we'll look at the physics of why you would even want to do that. Spoiler. It involves the freezing vacuum and the sun.
And we have to talk about the cost. Not the dollar cost, but the physical cost of the planet. Because there is a dissenting view in this material that is, well, it's frankly terrifying.
The metal shell.
The metal shell. It sounds like a bad sci-fi horror movie, doesn't it?
It does, but based on the data we have here, the physics behind that idea are deadly serious.
So whether you're the kind of listener who gets excited about the absolute bleeding edge of AI and engineering, or you're someone who really worries about space junk and the future of the night sky, stick around. This affects everyone living on the surface of this planet.
Which is, statistically speaking, all of us.
For now, anyway. Okay, let's get into this plan. The source material lays out this conversation about the filing. And the first thing that just jumped out at me was the purpose. My first assumption, and I think everyone's, when you hear Musk satellite, is global Wi-Fi.
Right. Faster downloads.
Yeah, lower latency for gaming, that kind of thing.
That's the legacy model, the telco model. You beam data up, it bounces off a mirror, it comes back down. The satellite is just a relay. But the source material is emphatic about this. It says it's not for Wi-Fi this time.
No. They call them orbital data centers.
Right. And the phrase they use, which I thought was clever, is that they're literally moving the cloud into the actual clouds, or rather above them.
It's a cute line, but okay, let's treat this like an engineering problem. Why? Why would you do this? It seems so much harder to fix a server in orbit than it is to fix one in some warehouse in Virginia. Why move all that compute off planet?
Because we're hitting a wall here on Earth. If you look at the trajectory of AI, we're talking these massive large language models and whatever is next, we are running into two very hard, very real physical limits: heat and power.
The source mentions cooling servers with massive fans and water.
And they are incredibly thirsty and hot. If you go to a hyperscale data center, say out in the desert, a huge chunk of the infrastructure, sometimes half the energy bill, is just dedicated to stopping the chips from melting.
Right.
You need millions of gallons of water. You need these massive HVAC systems. It's an efficiency nightmare.
I was actually reading a side note about this, how new AI clusters are basically requiring their own dedicated power plants. Like they're having to recommission old nuclear plants just to power one AI training run.
Precisely. The grid is struggling. We are literally running out of electricity in certain areas to power these things. So now look at the space solution that's being proposed here. It's brute force, but it's also really elegant. What's the one thing space has an infinite supply of?
Nothing. Cold, empty, nothing. Vacuum.
And a vacuum is very, very cold. The background temperature of space is just a few degrees above absolute zero.
So, zero cooling costs.
Oh, to be precise, it's not zero effort. You don't have air in a vacuum, so you can't just blow a fan over a heat sink. You have to use radiative cooling.
Explain that for a second.
You basically have to radiate the heat away as infrared light. But if you design the satellite right, you're dumping all that waste heat into a heat sink that is effectively infinite and effectively at absolute zero. You don't need water. You don't need AC units.
You just strip away all that support gear. You just point the hot side of the satellite at the dark.
And it is a massive gain in efficiency. You are using the environment itself to solve your biggest thermodynamic problem.
Okay, that handles the heat. But you still need the electricity to run the chips in the first place.
And that's part two of the equation. The source calls it infinite solar power.
Which, I have to say, sounds like marketing fluff.
Hmm.
Infinite is a pretty big word.
It sounds like it, but think about it. Down here on Earth, even with a solar farm in the middle of the Sahara, the atmosphere scatters and blocks light.
Right.
You have dust, humidity, clouds, and of course you have the biggest problem of all.
Nighttime.
Nighttime. For 50% of every day, your solar panels are just dead weight. You need these huge, expensive battery farms to bridge that gap.
But in orbit.
In orbit, if you place these data centers high enough, or in what's called a sun-synchronous orbit, you can get near constant illumination. You are above the clouds of the atmosphere. You have access to raw, unfiltered sunlight 24/7.
The energy density is pure.
Exactly. So if you connect the dots here, like the source does, this isn't just about moving computers, it's about removing the limits.
The source calls it the ultimate growth hack for AI computing.
And that phrasing really, really struck me. Because right now, AI is limited by how many GPUs we can build and how much power we can feed them without melting the local grid. If you move that whole system to space, you remove the heat constraint and you remove the power constraint.
And suddenly, the ceiling for how powerful an AI you can build just gets a lot higher.
Infinitely higher, in theory, yes. You are decoupling intelligence from the biosphere. You can scale the brain without, burning up the planet in the process.
When you put it that way, it sounds almost noble, like the ultimate green solution. You're just exporting the entropy.
You're moving the industrial byproduct, which is heat, off-world. It's the ultimate not in my backyard, except the backyard is the entire planet Earth.
And this is a huge but. We have to talk about the scale, because this isn't a few dozen orbital data centers.
Yeah.
It's 1 million.
Yeah.
Why 1 million? Why on earth do you need that much compute?
And this is where we get into the, let's say, the philosophical part of the source material. It references a concept called the Kardashev Scale.
I saw that. Kardashev type 2.
Hmm.
It feels like we're jumping from engineering straight into, like, deep sci-fi here. Can you break down what the source says that actually means?
The source defines it really simply and very starkly. Total solar dominance.
Total solar dominance. It sounds intense.
It is. So the Kardashev scale is basically a way to measure a civilization's technological level by how much energy it can use. A Type I civilization can use all the energy available on its home planet.
Which we are definitely not. We're still burning dead plants for most of our power.
Right. Or maybe a Type 0.7 on a good day. But a Type 2 civilization, that's the big jump. That's when you stop just using your planet's resources and you start harvesting the energy of your star directly.
And that's the mindset shift the source is getting at. This isn't just a business plan, it's a civilizational step up.
Exactly. And Musk's justification, according to the source, is that anyone who worries about the number, about 1 million, is just thinking too small.
Yeah, I remember that line. Space is beyond comprehension vast.
He's basically arguing that our intuition about crowding is totally wrong because it's based on Earth scales. Here, 1 million cars is a traffic jam, 1 million people is a city. But in the sheer volume of orbit around the Earth, he's arguing it's functionally empty.
He thinks 1 million satellites just fittins.
He thinks it fits easily. To him, it's like adding 1 million drops of water to the ocean. You wouldn't even notice. And if your goal is total solar dominance, if you're trying to power a superintelligence by harvesting the sun, then 1 million satellites isn't just a lot. It's the minimum requirement.
It's the necessary infrastructure for becoming that next tier of civilization.
From the proponent's perspective in the source, the Alex view, yes, this is how humanity grows up.
However, and this is where the record just scratches to a halt, because there is another perspective in this source material. We've got the Alex view, the excitement, the growth hack, and then we have the Sam view.
The dissenting view.
And this is where the deep dive takes a turn, because Sam looks at that number 1 million satellites and does not see a growth hack.
No.
What do they see?
They see a metal shell.
A metal shell around the entire Earth.
Yeah.
Let's visualize that. We're not talking about looking up and seeing the stars anymore. We're talking about a web of metal so dense that it effectively encases the planet.
And the primary risk here isn't aesthetic. I mean, it's not just about ruining the view for astronomers, though that's a huge problem. The real risk is kinetic.
The debris problem.
The source is very, very specific about this. It mentions space debris. But I think when people hear debris, they think of, a plastic bag floating in the wind.
Right. Just trash.
In orbit, there is no trash. There are only projectiles. We're talking about objects moving at roughly 17,500 miles per hour.
17,500.
At that speed, a fleck of paint hits with the kinetic energy of a hand grenade. A single loose screw hits like a tank round.
So walk us through the one collision scenario that's laid out in the source. Because with 1 million data centers whizzing around, the odds of a fender bender have to go up.
If two of these satellites hit, they don't just get a dent, they vaporize. They shatter into thousands of pieces of shrapnel. And every single one of those pieces keeps that orbital velocity. It keeps moving at bullet speed.
And in a metal shell, that shrapnel doesn't just fly off harmlessly into deep space.
No, it stays in the shell. And it hits other satellites, which creates more shrapnel, which then hits even more satellites. It's a chain reaction.
Lassler syndrome.
Exactly. The source calls it a wall of shrapnel. Think of it like a shotgun blast going off in a room full of mirrors. One hit becomes 3, 3 become 10. It just cascades. It's exponential.
The source describes the end result of this in a way that, man, it really stuck with me. It says we could be trapped on Earth forever behind a wall of shrapnel.
That is the nightmare scenario. We talk about the infinite freedom of AI growth, but the physical consequence, the counter-reaction, is the total imprisonment of humanity.
It's a perfect paradox, isn't it?
It is, because if that chain reaction happens, you can't launch rockets anymore. Anything you try to launch gets shredded before it even clears low orbit.
We couldn't get to Mars. We couldn't repair a GPS satellite. We're just stuck.
Stuck. Underneath a permanent cloud of high-velocity bullets that we put there ourselves.
Trapped on Earth forever. That phrase from the source is just haunting. It contrasts so perfectly with the infinite solar power idea.
And that is the absolute core of the tension here. This isn't just a technical debate. It's a battle between two completely opposite extremes.
Okay, let's synthesize this, because this is the real debate the source is putting in front of us.
On the one side, you have this drive for Kardashev Type 2 status, this push for unlimited energy, unlimited compute, the ultimate growth hack for AI.
Which requires using the vacuum of space, using the sun's power. It requires that 1 million satellite shell.
Right. It's an argument for dominance. Dominance over energy, over information. It's about building a godlike intelligence.
And on the other side,
You have the risk of entrapment, the possibility that in reaching for that godlike power, we accidentally build our own cage.
a debris cage that locks every human in.
Exactly. It forces you, the listener, to ask, is the growth of an artificial intelligence worth the permanent ruin of our planet's orbit?
It's such a wild trade-off. I mean, the sci-fi nerd in me just goes, yes, put the servers in the vacuum, use the sun. It sounds so clean, so efficient.
And in a perfect world, it is.
But then you have to look at the reality of the filing. You have to look at the math of 1 million objects all moving at 17,500 miles per hour over our heads.
And you realize that space is beyond comprehension vast, might be true for the universe, but low Earth orbit, that is a very finite resource.
It's a parking lot, and we're talking about parking 1 million buses in it.
And if just 2 of those buses crash, the entire parking lot closes. Forever.
That is a very sobering thought.
It really raises a question of stewardship, doesn't it? The argument is that we're thinking too small. But the counter-argument is that this plan is gambling with something that belongs to all of humanity, the sky itself.
And our access to everything beyond it.
Correct. If the metal shell happens and the shrapnel wall follows, it doesn't matter how smart that AI becomes, we'll never be able to reach it, and we'll never be able to go anywhere else either.
I want to circle back to something we touched on, because the dissenter, Sam, also flagged this, the environmental cost of just getting them up there.
Right. To get 1 million satellites into orbit, even with something like Starship, with fully reusable rockets, you are still talking about tens of thousands of launches.
It's a lot of rocket fuel.
It is. Even cleaner methane rockets, they still deposit enormous amounts of water vapor and soot directly into the upper atmosphere. We actually have no idea what the long-term climate effects of that much launch activity would be. We might just be trading heat on the ground for chemical changes up in the stratosphere.
So there's no free lunch.
There is never a free lunch in thermodynamics.
Yeah.
You're always just moving the problem somewhere else. The question is whether moving it to space is a net positive or a catastrophic, irreversible error.
Let's talk about the timeline for a minute, because sometimes these deep dives are about tech that's, 20 years off. But this filing, this implies it's happening now.
The planning is absolutely active. The technology is being built. The launch capacity is being scaled up as we speak. The only things really stopping it at this moment are regulatory approval and manufacturing scale.
So if you're a listener sitting there thinking, oh, this is sci-fi, this is 2050.
No, this is 2026, 2027 stuff.
Yeah.
This transition from communication constellation to orbital compute shell is the official roadmap.
It really changes how you look at the sky.
Mm.
I remember as a kid looking up and thinking about aliens or astronauts. Now I have to look up and think about data centers.
And traffic management.
It kind of takes some of the romance out of it.
Maybe. Or, maybe it just changes the nature of the romance. We are literally encasing our planet in a nervous system. That's pretty awe-inspiring in its own way.
That's a very generous way to put it. A nervous system.
Think about it. We are building a layer of pure intelligence, powered by a star, cooled by the void that wraps around the entire biological world.
But that brings me right back to the risk. If that nervous system has a stroke, if it crashes into itself, it paralyzes the host's ability to ever leave.
And that is the synthesis of this entire debate. Dominance versus entrapment. You cannot have the ultimate growth hack without also accepting the ultimate risk.
So as a listener, what should you be watching for? If this filing moves forward, what are the signposts?
Watch the regulatory battles. The FCC, the ITU, the International Telecommunication Union, they are set up to handle radio frequencies, not orbital congestion on this scale. They're going to be completely overwhelmed.
We're trying to regulate a space-age problem with, what, steam-age laws?
Pretty much, yeah. So if you start seeing approvals for mega constellations north of, say, 50,000 satellites, that's the tipping point. That's when we go from just crowded to shell.
And watch the collision reports.
Unfortunately, yes. We've had some very close calls already. If we see a major collision in low Earth orbit, two big satellites actually hitting each other, that is the canary in the coal mine. That's what starts the clock on the debris cascade.
It's moving the cloud, literally. But it might just bring the storm with it?
That's a perfect way to put it.
All right, as we wrap this deep dive up, let's just recap the stakes one last time.
We've got a proposal on the table for 1 million orbital data centers.
It solves the heat and energy problems for AI on Earth.
But it introduces the metal shell risk, a permanent wall of debris that could trap humanity on this planet forever.
It's the ultimate gamble.
Dominance versus entrapment.
I want to leave you with one final thought.
Hmm.
We didn't explicitly find this in the text, but it's just screaming at me from between the lines of this material.
Go on.
We're talking about building a massive network of computers powered by the sun, encircling the globe. If we build this metal shell to power a super-intelligent AI, has we built a brain for the planet? Or have we just built a cage for ourselves?
That is the question. A brain or a cage?
And the really scary part is, we might not know which one it is until we hear the lock click shut.
And by then, the key is already floating around in 1 billion pieces.
Oof. That's a little too real.
Just sticking to the source material.
All right, that is it for this deep dive. We've unpacked the filing, the physics, and the existential dread. The sources, including the discussion of the filing we analyzed, are available if you want to read the orbital math for yourself.
It's definitely worth a read. It really is the blueprint for the next decade of space.
Thanks for listening. We'll catch you on the next one.